In order to promote its cuisine, a new restaurant has decided to give away one of each of 75 different menu items. They will be distributed to residents in 3 zones of the cities in such a way that at least one dish is sent to each zone. Okay. In how many ways can the restaurant distribute the 75 items among the 3 zones? So that's A. Okay. After the giveaway, all the recipients decide to order takeout from the restaurant. If each person orders the same items they had originally received as a gift, how many ways could the take-out orders be distributed? So I'm going to answer B first, because B is what I would consider to be sort of a trick question, in that the answer is 1. There's only one way. Why is there only one way for people to reorder what they had already been told, or what they had already been given as a sample? Well, the question says they order the same items. Where are the choices? There are no choices. If one of the menu items you received was a carrot cake and you also got a Caesar salad, you go ahead and in question B, you order the exact same things. You're not making any choices. There are no choices anywhere. This is why I consider it a trick question. The answer is 1, because nothing's actually happening. Okay? It's the same way as sort of saying, how many ways are there of sitting 3 kids in a line if Albert has to go first, Betty has to go next, and Cecilia has to go on the very right? Well, there aren't. You've told me exactly what you want. There's only one way to do this. There's no choices involved. Okay? So B is a nice little trick question there. A is where some actual math is going to happen. So we've got 75 different items to give away. Each of the items could go to one of 3 zones. Okay? But we know at least one dish is sent to each zone. So it's going to be that same sort of at least, at most, trickery. Now, if I'm just talking about my 75 items, maybe we have zones A, B, and C. Okay? For the first item, right, we have 3 choices. Does it get sent to zone A, or B, or C? For the second menu item, again, 3 choices. Does it go to zone A, B, or C? Every single item has 3 choices. 3 choices, 3 choices. So just like when we were making subsets a moment ago, we multiply all our choices together. So 3 to the power of 75, that's a number of ways for the menu items, the 75 menu items, to just be sent to any zones. Okay? But included in this 3 to the power of 75 is, the situation where zone A gets every single menu item. And that's one of those 3 to the 75. Also included is the possibility that B and C split them all and A gets nothing. But we are told at least one dish is sent to each zone, so we have to correct that. Okay. So how do we do that? So 3 to the 75. Number of ways to send to any zone. We need to subtract some things. What we don't want is one zone to get all 75. Now, how many ways are there for that to happen? Think about it. What choices are involved if one zone is going to get everything? Well, which zone is it? It could be zone A, B, or C. So there's 3 choices as to which zone gets all the items. But then once I've chosen that zone B gets everything, I have 1 choice as to which zone menu item 1 goes to. 1 choice for menu item 2. 1, 1, 1. 1 times 1 times 1. This is going to be 1 to the power of 75. Just ignore it. Okay, so there's 3 ways for one zone to be getting everything. Just a question of which zone is it, A, B, or C. Then we get into the tricky one. The number of ways for exactly 2 zones to get all the dishes, the menu items. Okay. So before we enter that in, we'll put a little placeholder here. We don't want that to happen as well, so we'll take that away. Exactly 2 zones get everything. And it's the exactly, because I need to ensure that my zones do actually get at least one thing there. Okay? So first, what are we going to do? We'll choose which zones get things. Now I've got 3 zones to choose from. I could say, well, 3, choose 2. Or I could say, well, there's 3 ways to pick the zone that doesn't get anything. So there's 3 ways. Okay. I picked zone C, and therefore A and B get everything. Okay. So we choose the zones, and then send out the items, the menu items. How many ways are there to do that? Well, if we try and think it through, with our menu items numbered 1 to 75, menu item number 1 has 2 choices for which zone it goes to, right? Because we're only using 2 zones. Zone A isn't going to get anything, so it's either B or C. Menu item 2, 2 choices. Menu item 3, 2 choices. Does it go to B or C? B or C? You might say, okay, 2 times 2 times 2, 2 to the power 75. 3 ways to pick your zones, 2 to the 75 ways to split up your items to those 2 zones. And that's nearly it. But we're running into a problem that we've seen before. We said this is the situation where exactly 2 zones get anything. And it's possible that among these 2 to the 75 that every menu item is going to B. That's not exactly 2 zones getting all the items. Right? That's exactly 1 zone getting all the items. That was a completely different case. We've already dealt with that. Don't worry about that. Okay, so we need to avoid that. So minus the 1 way where zone B gets everything. And minus the 1 way where zone C gets everything. Okay. So it's 3 ways to choose your zones, and then 2 to the 75 minus 2 ways to split up the items so that each of these 2 zones that I've chosen gets at least 1 item. Okay? So that goes here. Right? And then we can go ahead and subtract. Okay? And you could simplify it a little bit. So 3 times 2 to the 75 minus 3 times minus 2 is plus 6. Well, the plus 6 and the minus 3 will turn into a plus 3, and that's about it in terms of the answer.